Okay, so we're going to look at writing roots in a different way today. Fractional, what it's called, which means that we're raising something to a power, but the power is a fraction. We started this the first time we did roots. Today, our lesson is all just practicing with this. So, a fractional power is the same as taking the root. So whenever you see something raised to a fraction, what you're really doing is you're taking the root. So, for example, 5 to the 1/3. Remember, the bottom number, the denominator of the fraction, is your index. Does anybody remember what the index is? Not your finger. It's that little number that goes in on top of the radical. So this is the same as taking the cube root of 5. So that bottom number becomes the little number in front of the radical, or on top of the radical. Do you guys remember this?
No.
Yeah.
Kind of. You remember taking roots other than square roots? Yeah. Okay, square roots do have an index. They have an index of what? 2. Okay, and that index is telling us how many times we want to multiply something by itself. So if we're taking a cube root, we're looking for what number times itself 3 times gives me the inside answer. If we're taking the square root, we're looking for what number multiplied by itself 2 times. Okay? So remember, like, if I'm looking for a square root of 100, I'm looking for what number times itself twice gives me 100. What is it? 10, right? 10 times 10 gives me 100. If I am looking for the cube root of 27, what number times itself 3 times gives me 27? 3. So the answer would be 3. You guys remember that? Okay. So square roots actually do have an index of 2. We just don't have to write it. So a square root would be the same as raising a number to what power? Not the second. It has to be a fraction. To the 1/2. So if you ever see something raised to the 1/2, that means it's a square root. You just don't have to write the 2. Okay? So let's look at some examples. Example 1. Just exactly what I was talking about. 25 to the 1/2. That is the same as the square root of 25. I want you to rewrite it using a square root first. And the square root of 25 is? 5. So your answer is 5. Yeah, that's all we have to do.
You just find the square root.
Okay, what about example 2? 64 to the 1/3. How would we rewrite that first? Not 3 square root. That means 3 times the square root. It is the cube root. That number is little. It's not in front, it's on top. So cube root of 64. And what number times itself 3 times gives me 64? 4. Okay? It is not a square root. It's a cube root. So far so good?
Yeah.
Okay, so what happens with something like this? Example 3. This is something we did in the last set of notes. Square root of 11 times square root of 11. I get to multiply the insides, so that's square root of 11 times 11, which is square root of what? 121. And what's the square root of 121? 11. So did we have to do all of that work? What did you guys notice about this? It gives us the answer. The square roots cancel each other out, right? So if I gave you something like square root of 5 times square root of 5, what would the answer be? 5. Okay? So if it's double, they cancel each other out and we get just whatever's inside. Okay, so what about number 4 then? What's the square root of 11, all of that, squared? Well, this is the same as square root of 11 times square root of 11, right? And what did we just decide square root of 11 times square root of 11 was? 11. So, what do you notice? It's the answer. A square root and a square are the opposite of each other. So they cancel each other out. So if you take the square root, or square of a square root, they cancel, and we're just left with whatever's inside. You see what I'm saying? It's like how addition and subtraction are opposites. If I give you 3 minus 3, it's going to be 0, right? They cancel each other out.
Yes.
Or multiplication and division are opposites. 3 divided by 3 cancels each other out. Square root and square cancel each other out. So we're left with just whatever's left inside. Okay? Okay. Moving right along. Okay, so example 5, I'm going to show you the long way first, and then we will find the shortcut. So, 2 square root 5, all of that squared. What's that the same as saying? 2 square root 5 times 2 square root 5. And we can do that, right? That is 2 times 2 square root of 5 times 5. Okay, so what would that answer be? 4 square root 25. And what's the square root of 25? 5. So this is 4 times 5, which is 20. Okay, here's a shortcut. If we have something inside raised to a power and everything inside is multiplication, that's the most important thing. It must all be multiplication. We can take this guy and distribute it to everything inside. So this would be the same as 2 squared times square root of 5 squared. What's 2 squared? 4. What's the square root of 5 squared? 5. They cancel. What's 4 times 5? Same answer. Does everybody see how these are the same? If I distribute the squared inside, the first thing is 2 squared. What do I get out here? 2 times 2, which is 2 squared, times 5, square root of 5 squared, which ends up giving me 5. All of it is exactly the same, just in a shorter amount of space. You can do it either way. The most important thing is if you're going to do it this way, it must be all multiplication. So must be multiplication only. Okay? So if you have something that looks like this, 2 plus square root 5 squared, you cannot do that. You have to expand and FOIL. Okay? So you cannot do it like this. Has to look like that. Okay? Okay. Example 6. Square root of 5 times square root of 6 minus 12. What does this look like? Distributive property, so let's distribute it. So this is the square root of 5 times the square root of 6. Square root of 5 times 6 minus square root of 5 times 12. That's 12 square root 5. We have to put the number in front. Okay, so make sure you put the whole number in front. Okay, can I simplify this?
Yeah.
This is square root 30 minus 12 root 5. Can I take this or simplify square root of 30? 3 times 10, but neither of those are perfect squares.
5.
5 times 6, but neither of those are perfect squares. 15 times 2, neither of those are perfect squares. So can I simplify it? No, so this is your answer. You just leave it like this. We have not started adding and subtracting yet, so we're done. We will, yes. Okay. So what about example 7? Distributive again? Yep. So let's distribute 3 root 7. So So this is 3 root 7 times 2 root 14. So 3 times 2, square root, 7 times 14, plus 3 times 5, square root 7. So we multiply the whole numbers, and then we just attach and we multiply the roots. Since this one doesn't have a root, we just attach it to the end. Okay, let's simplify. This is 6 square root 98 plus 15 square root 7. Can I simplify the square root of 98? You can. How can we rewrite 98 using a perfect square? 49 and 2. Good. So this is 6 square root of 49 times 2 plus 15 square root 7. Now what is the square root of 49? 7. So this is 6 times 7 square root 2 plus 15 square root 7. And what is 6 times 7? 42. So 42 root 2 plus 15 root 7. We cannot combine these because the roots are not the same. So we leave this as our answer. I will talk to you all tomorrow about adding and subtracting roots. So today we are just leaving it as it is. Okay?